All right. Derivatives of inverse trig functions, integrals of inverse trig functions. Let's review inverse trig, and we can write inverse sine of x like that, or we can write arc sine. So arc sine and sine with the -1 mean the same thing, but sine to the -1 doesn't mean 1 over sine. So this is not meaning the reciprocal, it means the inverse function. Let's look at how to find the derivative of this. So we know that the inverse sine of x means sine of some angle equals x. So we can say that the inverse of x equals an angle, so sine of the angle equals x. And now let's represent that with a graph. We know that's y over r theta. The y value is x, r is 1, and then find the horizontal value, or the x value. So that'll be 1 squared minus x squared square root. Now we have to remember that the derivative of an inverse is 1 over the derivative of the function. But I wouldn't put an x here. To make it clear, why don't we put a theta there? So sine is a function of theta. Inverse sine is a function of x. One more thing, we need the derivative of that. So the derivative of the inverse is 1 over the derivative of the function, but these are usually not the same numbers. So we keep on going. The derivative of sine is cosine. And then we can go back to the graph and see that the derivative of cosine is, cosine is this over r. So then that is just that. And there's the formula for the derivative of arc sine, or the derivative of inverse sine, is 1 over 1 minus x squared. And then we have to remember the other functions. And we have the derivative of arctangent is 1 over 1 plus x squared. And the derivative of arcsecant is 1 over absolute value of x. So we just have to have this and these two memorized, and then that'll cover what we need to know. All right, how do we find the derivative of this? Well, it's just the chain rule. So arc sine is 1 over radical 1 minus x squared, u squared. This is u, so it's just going to be in there, and we'll multiply by its derivative. So we could say this is the derivative of the outside is writing all of this. Leaving the inside the same means put that in place of the variable in the formula, and then times the derivative of the inside, 2x. There's not much else to do. Let's just write it like that. Okay, pause the video and try that one. One over 1 plus u squared. And in this case, so this is the derivative of arctan, 1 over 1 plus something squared, and that something is 2x plus 1, times the derivative of 2x plus 1, and well, it can be reduced, but we can just stop on that one. All right, so now we have arcsecant. Go ahead and try that one. Pause the video. So write down the formula for arcsecant. 1 over absolute value radical something squared minus 1. And here the argument is 4x, so that's going to be a 4x times the derivative of 4x. So we're doing the derivative of arcsecant. Here's the derivative of the outside, leaving the inside the same, times the derivative of the inside. Don't forget plus x squared, so that'll be a 2x. All right. All right, and pause the video, try this one. Slope and point slope. The slope is 1 over square root 1 minus x squared. So just arcsine, there's the formula for arcsine. We need the slope at 1/2. One-fourth, this is 4 over 4. Four minus 1, 3 over 4, so we have radical 3 over 2, because here we're going to have 3, so it's radical 3. Radical 4 is 2, so it should be 2 over radical 3. That's the slope, and now we need the point slope formula. We know the x value, but we have to find the y value. So we need f of 1/2, and that is arcsine of 1/2, which means find the sine of an angle that equals 1/2, and that's going to be 30 degrees or pi over 6. We can't use 30 degrees, let's use pi over 6. So we know that that's pi over 6. the slope that we found was 2 over radical 3 x minus 1/2. When you distribute there, the 2's cancel. We have 1 over radical 3, and then we'll just add pi over 6. All right, let's go on to integration. So we could memorize the formulas for integrals involving these forms, integrals that equal the inverse trig functions, but it just seems like they're used so infrequently that we'll just forget the formulas or get them mixed up. So I think it's better to use substitution. And we just need to make this look like one of those derivatives, 1 minus u squared. So that's going to be arcsine u is 2x, du is 2dx, dx is du over 2. One minus u squared, and then we have du over 2. So we have 3/2, and this is the derivative of arcsine. So now this is going to be the antiderivative is arcsine of u. We have 3 over 2 arcsine u plus c, and we know u is 2x. 3 over 2 arcsine 2x plus c. So the dx could be on the top, or it could be at the end, and that could be a 1. So try this one. We need to make this look like the derivative of one of the 3 inverse trig functions that we have considered. So pause the video and try changing this to look like one of the derivatives. So I'll put the dx over there, and we have, in making this look like arcsine, we want to, it can't be arctangent because there's a radical, and it's not going to be arcsecant because there's no variable in front. So this is going to be arcsine. We want to make this turn into a 1. Let's factor a 4 out of both of them. So there's a 4 on the outside. I took a 4 out of this, it became a 1. If I took a 4 out of this, I would have to put a 4 in the denominator, so that when I distribute, it would be x squared. So this, by distributing, we can check to make sure it was factored correctly. Then radical 4 can come out as a 1/2. It could be inside or outside the integral. And then we need to make this be one thing squared. It can't be a square on top and not a square on the bottom, so it's x over 2 squared, and that's what u is. So let u equal x over 2, du is 1/2 dx, 2 du is dx. 1/2 So we let x over 2 equal u. We have a u squared, and dx, the differential of x, is 2 du. So we can put the 2 outside. That's 2 over 2, or 1 minus u squared du. Antiderivative of this is the derivative of arc sine, so the antiderivative of this is arc sine. And we know that u is x over 2. All right, so we have no radical in this one. That means it must be arctangent if it's going to be anything. So let's make this look like 1 over 1 plus x squared. That has to be a 1, so we have to factor out a 2, and then it'll be a 1. If we take a 2 out of this, we have to put a 2 in the denominator. If you distribute 2 times 1, you get 2. 2 times that is going to take us back. So we know that's factored correctly. And we can take it on the outside. And then this has to be one thing squared. So it has to be 3 over radical 2x. 3x over radical 2 squared. If you square 3x, it's 9x squared. If you square radical 2, it's a 2. So we know that is the correct form. This will be u. U is 3x over radical 2. Du is 3 over radical 2 dx. Radical 2 over 3 du equals dx. So we have 1/2 integral 1 over 1 plus u squared radical, that should be a radical 2 over 3. We have radical 2 over 3 du. And that's coming from here. We have u, so 1 over 1 plus u squared. 1 over 1 plus u squared dx is radical 2 over 3 du. Radical 2 over 3 du. And now we can put that on the outside. That'll be radical 2 over 6. This is the derivative of arctangent. So now we have arctangent of u and u was 3 over radical 2x plus c. Last example. Alright, so it's going to be arctangent. Pause the video and try rewriting that. Arctangent has to have a 1 plus something squared, so we need to take out the 4. All right, we took a 4 out of this, and there's a 1. If we take a 4 out of this, there'll just be a 4 in the denominator. This has to be one thing squared instead of only a square in the numerator. We can put the 1/4 in front. So if we square that, it would go back to that, and now we can see what u is. U is x minus 1 over 2, and du is 1/2 dx. Because this is really just 1/2 x plus 1/2, so the derivative is just 1/2. 2 du is dx. And now we'll substitute back into this. So we have 1/4 integral 1 over 1 plus u squared dx. 1 plus u squared dx. 2 can come out in front. That's 2 over 4. So we have a 1/2. 1 over 1 plus u squared. This is arctangent of u, 1/2 arctangent u plus c, and u is x minus 1 over 2, and we'll stop there.